Ooh, Lord.
He's so stupid.
He skipped arm day, obviously. Yeah, Pansy, just do it.
Just do it.
Nike style.
Oh. Oh.
It doesn't make any sense.
Why would it explode like that?
Would it explode?
It wouldn't.
Why?
Well, I mean, but you put a firecracker in the toilet, it explodes.
That has nothing to do with this. You connect it to the battery, right?
Yeah.
It's like the wire's touching the water the entire time. Wouldn't
Right.
the current spread out across the water? Or would it go in?
Well, I mean, if you got the plastic around it,
They didn't have plastic though, because he connected it right
just
to the
wire.
battery. It was just a straight piece of cable.
I was about to say, oh yeah, just he was holding it.
Yeah, he was holding that. Oh, that would shock him, wouldn't it?
Yeah. Hold on, let's 50,000 volts.
Yeah. Dude, we should test that.
We absolutely
Bro.
Because, like, thinking
Bro,
about, like,
protection.
terms of current and circuits and stuff, wouldn't it, because the current's going to hit the water, right?
Oh,
And
yeah.
wouldn't it spread out because water conducts?
Well,
And it would act like a second wire, kind of?
a second infinite wire, though, which is what's it connected to. Right, what's the next thing? Where does it go?
I don't know.
Then it would just stay in the wire that he shot him with, right?
Maybe. It depends, like, how much resistance the water
Also,
has
you're supposed to be dead.
versus the wire, right?
Right.
Yeah. We should test this.
We should.
Let's
you think
go.
we could light up a light bulb with it?
Light bulb's a good idea. That way we can easily test.
We need something.
Mhm.
We can't blow up a shark, but...
Maybe you can. Not that attitude.
There's talk.
Let's just spit really quick, okay.
Let's do this thing.
So you've already stopped our watching of Deep Blue Sea because you don't agree with the way they murdered the shark.
That's because it's garbage.
How are we going to test that you're right, Garrick?
Alright, so what I'm thinking is that we have a battery here.
Because that represents our car battery in the movie, right?
Right, because LL Cool J is like, wire our battery into the water. But we want to test here is that if the current through that wire, when it hits the salt water, if it's going to disperse across the surface, or if it's going to keep going
Because
through.
water conducts electricity.
Right, right.
Yeah.
You want to see if
Especially salt water.
Yeah, exactly. Salt water does an even better job. So we want to see if that's true or not. So we have our car battery, and then we have that cable that he uses via actual wire, and then also some aluminum foil. So what we're going to do is connect our battery and our wire here. Dangle this wire over the edge of the tank like this, which is filled with salt water. Then take the aluminum foil and connect it to a light bulb in the middle. Now we know they don't use a light bulb in the movie, but that's all that we have access to because
Yes.
black powder is dangerous.
At Brown.
At Brown. And then what we're going to do is connect the other side of the light bulb out again through the aluminum foil. And if the light bulb lights up, we know that the movie was actually right.
And the light bulb represents our exploding shark.
Right, exactly. And we have to connect the circuit, which LL Cool J didn't have to because it was black powder, something that just ignites when current's there. But to test current, we have to use light bulb. So that's
Because...
basically it. You guys ready to do this thing?
Oh yeah.
Let's do it.
No. So what we've done here is created the scene from Deep Blue Sea as best as possible. We have our battery, which is like the car battery that he uses in the movie, and we have that connected to this wire. It's going to go up through here and into this fish tank full of salt water. These two aluminum strips are going to act like that cable he had in the movie. But unlike the movie, we had to finish the circuit because all we have available to us is a light bulb because black powder is too expensive and too dangerous for kids to buy. Lame. And then it's going to follow back through here, and we're just going to connect it just like this and see if it lights up. Hopefully it works. So that's what we've set up here. Only one way to find out.
Only one way to find out.
Count us down, Casey.
Let's do it.
3, 2, 1, light. Alright guys, so the myth that a current will travel through a wire as opposed to salt water is...
Confirmed. You know, that box only gave us a marker meter of wire.
What the heck is a marker meter? Hold on, wait, that's gotta be made up, right?
It's a Brown original. But it did come without difficulties though.
Yeah.
I mean, we waterlogged the light bulb.
Yeah, first time we tried.
We absolutely waterlogged the light bulb. We had to hot glue this one.
Oh, shh. Oh. Well, we had to hot glue that one. You alright there, son?
Yeah, I'm gonna be right back.
You should have dodged faster.
I was such there, it hit me hard because it was falling horizontally.
That doesn't make any sense.
Yeah.
It does?
No, it doesn't.
All right,
Yes, it does.
you want to test this?
Yeah.
Bet, boy.
Let's go.
Let's go.
Let's go.
So the core idea of this myth is that if something is fired off of a level surface versus something dropped at a level surface, if they'll hit it at the same time. So what we have here is a level surface. That's what this level shows here. It's completely level. And what we're going to do, move this out of the way, simply take this ball, drop it at table height, see how long it takes to hit the ground. Then we're going to do the same thing, but we're going to give it some velocity in this direction and see how long it takes to hit the ground. And we can compare the two times, see which one's faster, see which one's slower, and test the myth. Ball drop, 6.35 seconds. Next one, 5.89 seconds. Okay, Seth, what's the difference?
46.
0.46 seconds. 6.60 seconds, because significant figures. Next one, 6.21. No, 17. I can't hear. What's the difference, Seth?
43.
Point
I like that math.
4.3 seconds, and I hate you. So the difference that we got should have been 0.
It should have been.
Right?
If it's the same.
I mean,
But
you think about it in forces, right? The ball dropped has a free body diagram like this,
Right.
and as soon as it's dropped, the only thing acting on it,
It's gravity.
is
Right.
gravity.
and the slight air resistance, but who cares?
You're right.
And then we have the ball roll.
Here.
The same thing's gonna happen. Sure, it's gonna have a velocity to the right, but there's no force there. But
Right.
it's constant acceleration.
Well,
So we're just gonna have that
not
same-
constant acceleration. Oh, well, yes.
Isn't it? Because there's nothing acting in the X direction other than that initial
If
velocity.
you know your air resistance, then yes.
Yeah, air resistance is dumb.
Correct.
So force of gravity
You don't
here,
know how to calculate that. Be quiet. you
force of
two
gravity
students.
here, and those force of gravities should be the same. Same ball, same gravitational field strength.
Yeah.
So why do we get a difference?
I think it's because we had a problem with the frame rate on the iPad, giving us very stunted milliseconds. So I think it would have been a problem where we go frame by frame, but the milliseconds didn't catch up.
Guess we should leave him with the final message, huh?
Final message.
I know you wanted to hear us sing Brown, which is why you always do the music videos. So we do have a song for you.
We did create a small little piece.
Small little piece, but you know.
Garrett, you want to lead us off?
You guys ready?
Yeah.
1, 2, 3.
Jip,